been building up to with all those different skills that we've been practicing. I have 3 different kinds of log equations for us to solve. One where there's 1 log on one side of the equation, one where there's 2 logs on one side of the equation, and then the piece de resistance, 2 logs on one side, 1 log on the other side of the equation. We're going to try solving all of them. And when you're solving log equations, remember all you're trying to do is isolate x. And what undoes a log equation? What's the inverse of a log equation? An exponential equation. So a lot of these are going to have something to do with isolating x and probably using an exponential equation in order to do that. Except for the last one, that one will be different. So here, there's x, and I want you to know, when you see x in, like you've got your base, answer, your exponent, and then you have 4 out here, that's just like 4 times the log. When you've got x in where the answer is, that's all tied up with the log. So I don't want you to think that you could just subtract the x to move it, or that you could divide the x to move it. You can't do that. It's all tied up in with the log, which is why eventually we're going to have to do exponential form to get rid of that log. But the first thing we want to do is we want to get rid of this 4. Now don't distribute it in. That doesn't make any sense. Mathematically, that is not even something you'd be allowed to do. So how are you going to undo this 4 times the log? Well, you're going to divide out the 4. So those are going to cancel, and that's going to give you log 3x equals 20 divided by 4 is 5. Okay, and again, this x is all tied up in there with the log. So now we want to undo the log. We want to get rid of the log so we can move it away from the x, so that way x will be by itself. How are you going to do that? You're going to put it into exponential form. So we know that 3 is our base, 5 is the exponent, and x is the answer, because log is bay. So 3 is the base, x is the answer, 5 is the exponent. Now you can see that 3 to the 5th power equals x. Now you can figure that out. Now you know what's 3 to the 5th power. What's 3 times itself 5 times. That's 200. I wrote it down so I wouldn't make a mistake. That's 243. 3 to the 5th power. Well, let me just come up here. 3 to the 5th equals x. 3 to the 5th power is 243. So 243 equals x. If you want to check your answer, because a lot of times your teacher will say, make sure you check your answers, then what you can do is you can just solve it out in your head, which would be the same as doing this, or you could plug it in your calculator. You could just plug 243 in here to make sure you got 20. If you had a calculator, you could check it that way, but try checking your answers. So that's the first example. Here we go with example 2, still solving log equations. Now I have 2 logs and they're both on the same side of the equal sign. So let's solve this out here. First thing we want to do, a lot of people make a mistake, and when I say a lot of people, I mean a lot of the students that I've had over the years will make the mistake and they'll think, oh, well, we'll just kind of like add these together somehow and then subtract or whatever. No, you have to use your properties of logs, which to me are not intuitive, which is why you got to learn your properties of logs. You'll know that when you're adding 2 logs, what you're really doing is you're really multiplying these numbers that are in the answer position. And you remember in the property of log video, I told you we're going to use our properties sometimes when it helps us get to the end of the problem. And here it is. So we're going to take these 2 log expressions and we're going to combine them together to get log 3. And then we're going to multiply the x and the 5 together, which is going to give us 5x. And I like to put it in parentheses just so that way I know that it's all stuck together. And then equals 4. And remember, like I said earlier, this, let me get a new color. This 5x and the log, those are all tied up together. So don't think you can like divide off the log 3 or something to undo the log. No, to get rid of a log and to get that x by itself, now you're going to need to use exponential form. So you have base, answer, exponent. So rewrite it in exponential form. So get a new color. So my base is 3, my exponent's 4, and my answer's 5x. Okay, just like in the last example, now we're going to make some more space for ourselves. There we go. 3 to the 4th, I wrote this down too so I wouldn't mess it up. 3 to the 4th is 81. Equals 5x. And now we just finished getting x by itself. We need to get the 5 away from the x. That says 5 times x. Undo it with division. You could leave it as 81 over 5 if you felt like it. I don't personally love fractions, so I turned it into a decimal. 81 divided by 5 is 16.2. So 16.2 equals x. How can you go back and check that? I would probably just plug 16.2 in here for x, stick this in my calculator, make sure it came out to 4, and that's how I know whether or not I had the right answer, which I did do that earlier, and I do have the right answer. This is how you do it. Up next, example 3. Here we go with example 3, the one that I told you would be just amazing. We've got 2 logs on one side of the equation and another log on the other side of the equation. Obviously, you'll notice as we've had in all of our examples, all the logs have the same base. I'm sure you could do some where they didn't have the same base, but that's not what we're doing here. Ours have the same base. And if you've been learning about these in class, you might get excited when you see the same log with the same base on both sides of the equation, because you know that you're going to get to cancel those out and not even have to deal with the log. But a lot of people think, oh, I can just cancel all 3 of these out and I'm good to go to solve the problem. False. You still have to use your properties of logs. So here we see that we are subtracting 2 logs from each other. That's the subtraction quotient property. So we need to combine these logs together first. And when we're combining logs through subtraction, we're going to be dividing what I call the answer to the log. So that's going to make log 20 and then x plus 1 over x minus 2. So now it's combined and then equals the log 20x. Log 20 1/3. Put parentheses around these. Okay. Now that we've got it, now that we've got it where we've boiled it down to a log 20 on the left and a log 20 on the right, now's the point where we get to start canceling out those logs. So we get to cancel off the logs, and now we just have the equation to solve. And now we just got to solve that for x, just like we've been solving our whole lives with algebra. I personally like to cross multiply here. So just cross multiply, so we have, let's make some space. There we go. So 3 times x plus 1 and 1 times x minus 2. So distributing the 3 and the 1, so we get 3x plus 3 equals 1x minus 2. And then we just start subtracting and adding and dividing to isolate the x, minus the x, and I'm just going to go ahead and minus the 3 at the same time. And we get 2x equals negative 5 divided by 2. X equals, like I said, I hate fractions. I hate them, so I'm just going to go with decimals, negative 2.5. And you'd think that would be the answer, right? But like I said, your teacher's probably going to tell you to go back in and check it. There's 2 ways to check it, by hand or with a calculator. If you were to check this with a calculator, you'd plug in that negative 2.5 in these 2 spots to make sure it came out with the same thing that log 20 1/3 gives you. When you plug this in the calculator with the negative 2.5s in there, you get an error. Why do you get an error? Here's what you're going to need to know in case your teacher doesn't let you have a calculator. If I was to go back in there, hang on. If I was to go back in here and plug in that negative 2.5, let's just do it in the first bit because we don't need to go much farther than that. I would do log 20, and then I'd plug in the negative 2.5 here. and then negative 2.5 plus 1 is negative 1.5. And I have log 20, negative 1.5. And let's say we were going to evaluate that to figure out what number that equaled. So it'd be like equals something. 20 to what exponent can give me the answer negative 1.5? There is no exponent you could possibly fill in to turn 20 into a negative number. Can't be done. So that's how come we know that this is no solution. That's why your calculator would have given you an error message. That's how come this negative 2.5 is an extraneous solution. It looks like the answer, but it's not actually, and it's a good thing you check so that way you can get full points on your test and not just partial credit. So anyway, you would not actually give that as an answer. This case would be no solution. Sometimes they do have a solution, just this one didn't. Thanks for watching. As always, remember if you need help, my contact information is in the description. Hey guys, don't forget to like, subscribe, and check out my website at oliviashirleytutoring.weebly.com, where you can schedule one-on-one tutoring and contact me.